asked you and engaged you, you got all excited. Isn't it amazing how easy it is to reignite the curiosity of the human mind? I mean, if you look at little children, 4, 5, 6 years old, they're so curious about the world around them. They keep asking, why? They want to understand. If anything, education does a really good job turning this curiosity that we're all born with off. The good news is, I have just shown you how easy it is to turn it back on. Now, before I tell you the answer, let's analyze what happened here. Let's analyze the psychology of this a little bit. I asked you a question, and then you thought about the question, and then at the end I had you make a commitment. You had to say, I choose 1, or I choose 2, or I choose 3, right? By pressing a button. Or we could have done it hands on the chest too. And after you had made the commitment, I asked you to externalize your answer. You had to go to the person next to you and you had to say, I chose answer, And what was interesting that happened, and I could see it, because you all started to gesticulate like this, is that you moved away from the answer to the reasoning. It was no longer about it gets bigger or it gets smaller. No, it was it gets smaller because blah, blah, blah. Or it gets bigger because... So it was about the process, not about the answer. And lastly, you became emotionally invested in the learning process. If I were to tell you now, sorry, it's 3:25, I have to stop, bye-bye, you would come running after me and ask me, what's the answer? What's the answer? Right? Very different from when you're being just lectured at. Now, before I can answer, you need to vote again. So please vote a second time and indicate what you now believe to be the correct answer. If you've not changed your mind, you basically say the same thing again. If you have changed your mind, you indicate what you now believe to be the correct answer. Ten more seconds, so please indicate what you now believe to be the right answer. Uh-oh. The first time, only about 45% of you got it right. I thought I gave a very clear lecture. And so did you, because when I said, ask me questions, nobody asked the question. But by only having 45% correct, you actually have been telling me something very important. Because, in essence, you've been telling me, Eric, your lecturing sucks. So let's see what we have the second time. The correct answer is... Oh, look at that. Now nobody is sleeping. Everybody is looking at the screen. Even the row in the back there. The correct answer is... I need a drum roll, you know. Number... There's not one person texting or tweeting or... Number 1. And let's see what we have. Look at that. 70% got it correct now. I'll show you the initial distribution. This was before the discussion, and this is after the discussion. Correct, wrong, wrong. You see that the wrong answers go down, and the correct answers go up. Now, I don't want you to lie in bed tonight at 2 a.m. thinking, why does the hole get larger? So, imagine for a moment that we have a metal plate without a hole, no hole. We take a pen and we draw a circle. So now we have a plate with a circle. We put the plate with the circle in the oven. The plate expands. What happens to the diameter of the circle? It gets bigger. Everything gets bigger, so the circle gets bigger too. You say, that's unfair. There's no hole. If there was a hole, then the atoms would expand into the hole. I'll show you what's wrong with that. Let's imagine that we go outside and we hold hands. Each of us is an atom at the edge of the hole. We are the atoms at the edge of the hole. You, me, other people, right? We're all there holding hands. And now we step in towards the center of the circle. What just happened to the distance between us? What happened to the distance between us? It got smaller. We got closer together. We can't get closer together. The only way to make the distance larger is to remove some atoms, but atoms don't disappear, or to make the hole larger. You won't forget this. Anyway, back to peer instruction. The first time that I did this, I doubled the learning gains. And after a few years, I was able to triple the learning gains. And also to get better retention. Students remembered what they had learned longer because they had not just memorized it, they had internalized it. And many other instructors in many other countries have repeated the experiment and found better learning. And my book on peer instruction, the one that you see here in the background, has now been translated in Chinese, in Korean, in Spanish, in French, in Czech. It's amazing. Maybe one day there'll be a Thai translation of the book. So let's end by the following. What is it that happens in a lecture? In a lecture, students don't pay much attention. They can't pay much attention because they need to take down the information. You walk out thinking you know it. You thought you knew it about the expansion. You didn't ask me questions. You thought it was clear. But in reality, you had not yet been confronted with any misconceptions. You had not had time to think about it. So in the end, a lecture gives you a false sense of security. Students think they know it. Oh, this was a very clear lecture. The professor thinks, oh, I just gave a very clear lecture. There were no questions. But in reality, it's just an illusion. It's just a house of cards. So, education is not just about transferring information. It's not about getting students to do what we do. I want my students to stand on my shoulders and be able to reach higher. I want my students to solve the problems that I cannot yet solve. We need the students that we educate today to solve the problem that this generation cannot yet solve. And therefore, it's not enough just to lecture. I think active participation in the classroom, like I just demonstrated, is a must. So please, don't take these home. We need them. And if you want more information on peer instruction and who is using it, you can join this social network, peerinstruction.net, which permits you to look up who else is using peer instruction. You can type in Chulalongkorn University, or you can type in chemistry, or chemical engineering, or thermodynamics, and find other teachers who are using peer instruction or who are interested in peer instruction on this website. And lastly, if you want a copy of these slides, you can download them at this URL. I hope I uploaded them already. I think I did. If not, they'll be there tonight. Thank you very much for your attention.
Thank you for a very inspiring talk. We have a few minutes for questions. Does anyone have any questions? มีคำถามไหมครับถามเป็นไทยก็ได้ครับผมแปลอาจารย์สะทน Have you encountered a non-responsive classroom เคยเจอแบบห้องที่ไม่ตอบอะไรเลยไหมครับ
Actually, never, no. You know, sometimes there are people who do not want to be involved. That was the case here too. Usually in my class on the first day, whenever I do the first question, I run towards the back. And if there are students who are sitting unresponsive in the back, I start talking to them. They don't want that. So the next lecture, they move forward and they make sure that they're sitting close to a friend.
Other questions? Yes.
So the question is, has anybody tried this method in more advanced courses? Yes, absolutely. I have actually at Harvard a number of colleagues who have used this in upper level thermodynamics courses, quantum mechanics courses, electricity and magnetism, yes. I mean, once you get to the graduate level, first of all, the students are much more motivated. And secondly, the classes are much, much more smaller, right? 6, 8, 20 students. So it's automatically more interactive. So I think this is most effective in large introductory courses, but it can be used at any level because we learn not by listening, we learn by doing.
Perhaps we have time for one last question. If not, then we have one more. Okay.
Right. So the question is about the assessment. What do I do about the assessment? This is a very good question. And if you go to this website, you can have a whole talk on assessment. The video is on the website. But basically, what I do, I used to ask textbook problems. Now I mix conceptual questions and textbook problems. So I have many questions that cannot be answered simply by applying memorized equations. The students actually need to think. They need to think in words or images. Of course, it's very important to change our assessment because for the students, the assessment is the most important part of the course. That's what determines their grade, their mark. So if you look at my book on peer instruction, I actually have a whole section that's devoted to how to change the assessment to reflect this type of approach to teaching.
Okay, thank you very much. Maybe next year you'll be so kind as to come back and tell us about assessment.
Absolutely, with pleasure.
Okay. Let's thank the speaker again. Thank you. And this is the end of our lecture. Please go home safely.